So the first thing that we are doing is reviewing what triples are, Pythagorean triples. If you have some of these memorized, it's going to give you way less work in the future. So we're going to go over this so that you have way less work in the future. And I'm spending half of the day on this, so please, use that to your advantage. So Pythagorean triples are only for right triangles, and they only work if you know two of the sides for finding the third side. So the Pythagorean theorem, move this here. The Pythagorean theorem says if you know two sides of a right triangle, you can always find the third side using this formula. A squared plus b squared equals c squared, where c is the hypotenuse. C is the longest side. C is across from the 90 degrees. If you set it up wrong, you're going to get the wrong answer. We are going to use Pythagorean theorem only on 1 through 6. When you finish this worksheet, it will be using what's called Pythagorean triples. So we're going to use the Pythagorean theorem to find some of these triples. You might even have number 1 in your head from taking geometry, maybe not. Do you know the answer for this? Yeah, it's 3, 4, 5. That is a triple that is common. But if you did not know that answer, you would say, all right, this right triangle, I do not know the side that is across, that is opposite of the 90 degrees, which is my hypotenuse. That's my C. I don't know the C. So I would say a squared, 3 squared, plus 4 squared equals c squared. And we'd add those together. So we get 9 plus 16 equals c squared. So 25 is c squared. And we have the square root, and we get c is 5. Over here, my short leg is 3, my long leg is 4, and my hypotenuse is 5. So that is a triple, 3, 4, 5, that you will want to have memorized. So the next one. Does anybody happen to know a triple that has 5 and 13 as the hypotenuse? You know it. Did your teacher make it? You learn them last year? Good. And that's my goal, if you didn't have to learn them last year, that you learn some of them now. So when you look at this, 13 is the C, because it is the longest side, it's across from the 90 degrees. So we'll set this one up as 5 squared plus b squared equals 13 squared. So I'll have a 5 here and a 13 here. And then we're going to solve that. We'll get 25 plus b squared equals 169. So b squared is 144. And then you square root and you get b is 12. So 5, 12, 13 is a Pythagorean triple. Okay. Now, I'm going to stop talking for a moment, and you're going to find the rest of the first 6. This is the only time we're using the Pythagorean theorem today. So the rest of the worksheet, you will be using triples to figure it out. If you're behind, you still have time. You still have time to catch up. I'm just going over the next part because some people are on the next section. So I'm going to fill this out real fast. What's the next one? 7. Okay. So now what you're going to do is you're going to go to the next section, and you're going to copy these triples. So like right here will be 3, 4, 5, and then 5, 12, 13, 7, 24, 25, 8, 15, 17, and I'll copy those down in just a moment. But from there, you're going to be finding new triples, because you can find any triple by taking the original triples and multiplying all the numbers by something. So if I took the original triple, 3, 4, 5, and I multiply it all by 2, then I get 6, 8, 10. It's a new triple. It's related to 3, 4, 5. And then for the tens, you go all the way back to 3, 4, 5 again. We multiply everything by 10, and we get 30, 40, 50. So that's another triple that's related to 3, 4, 5. So your next step is to fill out the bottom table. Okay, so you guys should not just be copying down my answers, but doing them yourselves and then checking my answers. See, a lot of you didn't do the last one, but you have all of them done. So number 15 is a review from when we did radicals in chapter 5. Everything comes back in that. You can't just get away with learning something and forgetting it, because it always comes back. Number 15, you have to know how to multiply a square root with something that's not a square root. And I'm waiting until I see answers before I go over it. So you're just sitting here. Try something. Oh, it will not be a decimal answer. So you should be using your calculator, but you have to multiply it by it. And then if you have answer 15, there's a question at the bottom. Yes, Mark. Remember the rules about multiplying a square root. We have 3 square root 7, and we multiply it by the number 2. What can you actually multiply here? The 3 and the 2 together. You can't multiply a number into the radical. So we'll just have 6 square root 7, 8 square root 7, 10 square root 7. And when we do the factor of 10, we'll have 30 square root 7, 40 square root 7, 50 square root 7. So then the question at the bottom, looking at number 15, if all 3 numbers of a triple have the same radical, would you get a similar result as you did in number 15? If all 3 had the same radical. Right. Yes, you would. Why? Because when you multiply it, what? When we multiply what? The coefficient of the radical. You don't actually multiply the radical. What if you had what would be my third side of this triple? Jacob. What if you had a factor of radical 2? So now we're going to take those and we're going to multiply each one by radical 2. What's that first one be? 6. What would the next one be? 10. And is 6, 8, 10 another triple related to 3, 4, 5? Is 6, 8, 10 related to 3, 4, 5? So any triple that has 3, 4, 5 or factors of 3, 4, and 5 are all related to each other. So you're going to use these. And on the back of the page, you are not going to use Pythagorean theorem. You are not using Pythagorean theorem. You are using the front page. So you look at number 16 and you do not yell the answer out because this is now the homework. So you do not yell the answer out. But you look at number 16 and you see that this is a right triangle and you know 2 sides. You know 3 and 4. Now if you have it memorized, you can write down the third side. If you don't, look on the front. Figure out the third side and write it down. Don't use the Pythagorean theorem on the back. So you're going to use your triples. And hopefully you'll memorize some of them because of this. Hopefully. I'm saving a lot of time to listen to it. Alright. So I'm puzzling now. You'll have time in class to work on that at the end. So we're going to move on to the next set of notes, which are special right triangles. Special right triangles. Yeah, we're trying to finish that at the end. Before I start special right triangles, I just want to do some quick geometry review. When you have 2 triangles that are exactly the same, so I'm going to hit clone up here, and I have 2 exact same triangles. Do you remember what triangles those are called? Remember? They're not equilateral. That would mean something else, which we're going to go over today as well. But do you remember when they're exactly the same as each other? They are congruent, right? And congruent means all 3 sides and all 3 corresponding angles are the same. All the 3 corresponding sides and the 3 corresponding angles are the same. And we had shortcuts, and that's when you did proofs like SSS. These are all the same as SAS and stuff like that, but remember, we don't ever use. Don't worry, you'll use it in pre-calc. Well, really. But that's not for proving things the same. That's for something else. Anyway, so you guys saw that I copied this. It was exactly the same. Now what I'm going to do is I'm going to dilate it. I'm going to make it bigger. Now these aren't congruent. Vocabulary. They're similar. What makes them similar? What is still the same? The angles. If I took this and I put the angles on top of each other, that angle's going to be congruent. This angle's congruent. And that angle's congruent. So we have 3 corresponding congruent angles, and the sides are proportional to each other. Like if I multiplied, let's say that this side was 3, 4, and 5, and I multiplied every number by 3, then this side would be 9, 12, and 15. So it's proportional. They have the same scale. And that's why having triples is really important, because you can find these answers really quick. Also, what's really important is we're about to start trigonometry, and trigonometry has to do with the angles of a triangle. It has a lot to do with the angles, and it has a lot to do with similar triangles as well. So we saw that these 2 triangles have the same angles. Even if I shrink it or I grow it, stretch it, if I shrink it or I stretch it, like the angles are still staying the same. This will be very important for when we do trigonometry, SOHCAHTOA. Remember SOHCAHTOA? What'd you say?
I was walking by the secret trick today, and she was talking about this stuff.
Today?
Yeah.
Oh, yeah. What's SOHCAHTOA? Oh, we're going to learn that tomorrow. But you should have learned it in geometry last year. SOHCAHTOA. We're not learning that today. It's the relationship. It's the relationship of the angles to the side. Yeah. Alright, so to get there, we have to know two special right triangles and their side length relationships. We have to know the proportions. These triangles are always going to have the same angles. So the first special right triangle is a 45, 45, 90 degree triangle. 45, 45 are the two smaller angles, and then the big angle is 90 degrees. There is an extra square root 2 over here. Did you that? I don't know why it's there. If I have a 45, 45, 90, this is, give me a vocabulary word that this is this kind of triangle. Two angles are the same. Yeah, isosceles. So this is an isosceles right triangle. Good vocab there. 45, 45, 90. Because we have two angles that are the same, the angle determines how big the side opposite is. So since we have two angles that are the same, the side opposites of those are also the same. So the two legs, I'm going to call 1x. I'm going to call 1x. You don't have to write the 1, but I'm calling them 1x. And then the hypotenuse, if you know the side length, you multiply by square root 2, and you get the hypotenuse of x square root 2. Or if you know the hypotenuse, then you divide by square root 2 to get the side length. So it goes both ways. You multiply the short side to get the long side, or you have to divide to go backwards. All you have to remember is the short side is the 1x, and the long side is the radical 2 times x. I have tricks to remember this. There are two different side lengths in this triangle. And because there are two different side lengths, the radical that we are using is the square root 2. Because there's two different side lengths, I end up using square root 2 as the radical. And the hypotenuse, I'm going to say really funny. I'm going to call it the hypotenuse. So I can remember that the square root of 2 is part of the hypotenuse. I don't know how you say it, but I'm going to say it that way. I have all these tricks because there's not just one special right triangle you have to memorize. There's two special right triangles you have to memorize. So the other one is a 30, 60, 90 degree triangle. 30, 60, 90. This time, we have three different side lengths. Because we have three different angles, we have three different side lengths. So the radical that you'll see me using for the 30, 60, 90 is square root 3. Because we have three different side lengths for this. Because we have three different angles. So square root 3 goes into 30, 60, 90. They have ends. I'm going to use x's. I'm just changing these to x's. My short leg I'm going to call 1x. My hypotenuse I'm going to call 2x. So the hypotenuse still has the 2 in it. It's not square root 2 though. And then the third side, I'm going to be using x multiplied by square root 3. Or you can use n, it doesn't matter. So this one has a 1, a 2, and a 3 in it, but this time the hypotenuse doesn't have the radical. It's the third side instead. So you have to remember these. And doing your assignment will help you solidify that to long-term memory. The formulas are, if you know the short leg times by 2 gives you the hypotenuse. Or if you take the hypotenuse and divide by 2, you get the short leg. If you have the short leg, you multiply by square root 3, you get the long leg. Or if you have the long leg, you divide by square root 3, you get the short leg. Those are your formulas. So we have an example. Using more geometry terms. Find the altitude of the following equilateral triangle. What's equilateral mean? Equal sides. All the sides are the same. Equal sides. So I know that this is true. They're all 8. I have to find the altitude. Do you remember what altitude means? Height. But specifically, it starts at a vertex, it connects to the opposite side, and makes 90 degrees. So it is the height, but it has to start at the vertex. It has to go to the opposite side and makes 90 degrees. Something else that you learn in geometry. If a triangle is equilateral, it is also equal angular. What's equal angular mean? All the angles are the same. So if we've got 180 degrees for the whole triangle, all 3 of them are the same. Each angle is what? 60 degrees. So I know that these 2 bottom angles are 60 degrees. I know that one's 90. What do these 2 little angles have to be up here? They have to each be 30. Ooh, that sounds familiar. I feel like that's a special right triangle. Is it? 30, 60, 90. So I'm just going to copy one of those 30, 60, 90 so you can see what I'm doing and what I'm thinking here. So there's the 60 degrees. There's the 8. We have to find the height. So we use our formulas. Across from the 30 degrees, across from the shortest side is always, across from the shortest angle, smallest angle is always the shortest side. So across from the 30 degrees is always the 1 x. In a 30, 60, 90, we've got 3 different sides. So we're going to have a square root 3 somewhere. But when I go to the hypotenuse, what's the formula for the hypotenuse? It's on your paper. What's the formula for the hypotenuse? I'm saying the number 2. 2 what? X. It's going to be 2x. So the short side is 1x. The longest side is 2x. And then the middle side, the formula is x square root. Which one? 3, because there's 3 different sides. This one's going to have the square root 3. So I have to solve for the height, which means I need to know x. Right now I know that 8 equals 2x. So x has to equal, divided by 2, 4. So my height, or my altitude, is 4 times square root 3. The next one is U-track. The next one is U-track. totally didn't mean to connect those corners. Just I ran out of space. These don't have to be connected, but you're all like making sure they're connected. They're not supposed to be, but. Way to copy it is better, I think. I think that's correct. Is yourself? No blood. Yeah. You found the 5 that we had to do one more step. So for this one, you're finding the short side is down here, and the hypotenuse is 2x, so the short side is 5, which makes the height, which is x square root 3, 5 square root 3. That's all you have to do. Next one. Now we need to find the length of the side when we know the height is 10 square root 3. And it's still an equilateral triangle so that we know all the sides are the same. We also know that this is going to be 60 degrees, making this one 30 degrees. So we're just going to look at one of these 30, 60, 90. The side that I know is the x square root 3 side. So if I have 10 square root 3 is equal to x square root 3, how can I get x by itself? This is an equation. How can I get x by itself? Divide by square root 3. Divide by x is b multiplied. So we can undo it by dividing by square root 3. That cancels it out. Cancels it out there. What's x? Is that my answer? X is across from 30 degrees. So 1x is right here. So then my hypotenuse is the side I actually need, which is 2x. So my answer is yes. On this one or the next one? On this one? What's your question? Or you want me to come over and
This
look?
always works, so I solve it, and I solve it.
Okay, you can explain after we go over this, okay? All right, so the next one, we look at this triangle, and you cannot go by its looks. Remember, you're not allowed to assume. It's not always drawn to scale. What kind of triangle is this? So it's 45, 45, and then it has 90 degrees. So we know it's 45, 45, 90. So we look at our formulas for the 45, 45, 90. There's two different sides. The short side is 1x, but that one occurs twice. And then the long side, which is also the hypotenuse, one has a 2 in it, is what? X square root 2. So the hypotenuse always has the 2 in it, and the one with two different sides has the square root 2. So I've got set up, and I know that 7 is equal to x. So my A side is the same as my x side. So A is 7. And then my B is 7 square root 2. Whew. Right. Next one. You're finding C and D. So I'm going to put my formulas in. This is a 45, 45, 90. So the two sides are going to be 1x. And then the third side, the hypotenuse, is going to be x square root 2. So I have that 16 is equal to x square root 2. How do I get x by itself? Okay, so now I divide by square root 2, and we spent a whole chapter on square roots. So if I have x is equal to 16 square root 2, an alarm goes off in your head, and you say, hold on, in chapter 5, we weren't allowed to leave a radical in the denominator. So you have to rationalize that. You've got to get rid of that radical in the denominator. So we're going to multiply the top and bottom by a value of 1. That cancels out the radical in the bottom. You've got to make that into square root 4, which won't be a square root anymore. On top, I've got 16 square root 2. So now I have 16 square root 2 over square root of 4 is 2. And then you say, hold on. That reduces. Do I have decimals anywhere on the paper right now? I'm sleeping, and you're going to for that. 16 square root 2 divided by 2, something factors out and cancels. And we just did that last chapter. How do I factor 16 square root 2 on top? So that something cancels on the bottom. How do I factor that top? I factor 16 to be 2 times 8, and then square root 2. Since I factored it, I can cancel those. So side C and side D are the same. They are what x equals, which is 8 square root 2. So the only thing I might need my calculator for is if I didn't know what 16 divided by 2 was. Alright, you should not have decimal answers. Got it? So your assignment is to finish the rest of that Pythagorean triple page, and then the rest of basically everything I gave you today is the assignment. So there's the rest of the special triangle worksheet front and back. You guys have 9 minutes to work on it, which you can go back. So we're going to ask you questions, check answers with me.